All right, hello everyone. Today we are going to talk about what lies beyond GitOps and how to apply these GitOps principles to your actual real-life deployment to Kubernetes, especially when you scale to many, many clusters and many, many apps and tenants and environments. So I'm Kit. I'm a senior product manager from Octopus, and this is
G'day, I'm Rob. I'm one of the principal engineers here at Octopus.
right. So for the last year or even more now, Rob and I have been working on Kubernetes experience in Octopus, and we've been meeting multiple customers every week and ask them same question like, what do you like, what do you not like about Kubernetes deployments, and how hard it is for you. And we learned eventually that the problems people face are actually more or less similar, and the thing they're looking for are similar too. So we tried to combine it all in this one talk, and we will start about the best of all the most known and best concept for Kubernetes deployment, which is known as GitOps, what it is, why it's great. Then we talk about the common issues and limitations we see with GitOps, especially when people apply it at scale, and how we can address it with Octopus. And then at the very end, we talk about a hypothetical example and just a few quick tips on how would we configure deployment to Kubernetes in Octopus so we can benefit from all the best practices, but also avoid some pitfalls. All rightish. So let's talk about GitOps. So the thing is, GitOps is a vague term, right? There are no unified definition of what GitOps means. Lucky us, there is actual initiative called Open GitOps, and these people try to get together and just clarify the GitOps meaning. So we will use their terms and definitions, but it's very likely that you find a lot of other interpretation of the same term. So basically, in a nutshell, GitOps is a set of principles for operating and managing software systems. It doesn't tell us much, right? It's too generic. So let's talk about four actual pillars which usually define GitOps. So the first thing is GitOps and deployments with GitOps meant to be declarative. This movement started way before GitOps, and it's all about just instead of applying step after step after step to achieve my desired outcome, I want to define the outcome as a file, declare this in some kind of a manifest, and then my platform will do the changes, do the magic. I don't even know what exactly will be done, but eventually the platform will achieve the desired state which I declare. When I think about this, we naturally think about Kubernetes, but it's not the only declarative platform. There are multiple. The second one is deployment should be versioned and immutable. And that's an interesting one because basically what it says that once you have the desired state, you should be confident that nothing will be changed there behind the scenes. So it will be exactly as you left it. And then when you change it again, instead of changing the state, you'll create a new version of the state. And now you'll have two versions, version one, version two, and you can switch between them and always basically go back if the new version didn't actually work. The third one is pulled automatically. And this is a bit of a tricky one because what it actually says is just as soon as I have the new version, my deployment tool or my automation tool should identify that the version is there and get it instead of me doing extra effort and trying to basically push this configuration to my deployment target. And finally, it's about constant reconciliation. That means that my agent, automation, deployment tool should always check the status of my target. And if, for some reason, the status doesn't meet the desired state, well, it should be fixed. And there are multiple applications of that, which we'll discuss a bit later. Rob, which principle do you like the most of this?
Which principle do I like the most? I think the idea of having it sort of declarative is nice as an engineer, right? Being able to actually look at it. Let's have a bit of a chat now and talk through at a super high level what the GitOps flow actually looks like. In this scenario, we're going to deploy to a Kubernetes cluster. GitOps itself doesn't actually say anything about what targets you should be deploying to, but Kubernetes is the common one since that's part of where this GitOps movement kind of originated from. It's all about being declarative and immutable, just like GitOps. We're also pushing to a Git repo. Now, the first kind of mind-blown point here that I'll bring up is that GitOps, despite its name, actually says nothing about Git itself. It just fits really well into being declarative, versioned, and easy to pull from. I think this is sometimes the cause of some confusion from people. It creates some strong opinions, sometimes some hand-wringing when practitioners worry about what will happen if they stray from the gilded path. Yeah, so anyway, let's talk about this flow. So as an engineer, I designed my Kubernetes manifest. I add some details to it for a new pod, let's say. I push it to Git. I then got a CD agent, so that could be something like Argo CD or Flux, something that's sitting there watching those changes from the repository, takes a configuration and applies it into the cluster. In the case of Kubernetes, it will then take responsibility for ensuring that all the desired state meets the required state. So it's really nothing more complex than that ultimately. So why is it good, Kit?
Why is it good? And we're entering very opinionated territory, so be prepared. So I believe personally that GitOps is great because it gives you this one source of truth and the history. So basically, yes, I know what's running on my target, on my, let's say, Kubernetes cluster, because I can literally see the file, see the manifest. And it says exactly what's there. Number of ports, a container I want to run. I can examine this in a readable, human-readable manner. And also, I can see the difference between the previous version and the current version. Okay, something isn't working. Why? Oh, because the port was changed, or the container tag was changed, or something else. I can inspect that. The second thing is it's one process. We can manage our infrastructure or our deployment target configuration the same way we manage application code. There are some caveats, which we'll talk about later, but in general, having one process, maybe one set of tools, it's very convenient and very neat, and it bridges the gap between different teams, potentially if you have like platform teams or ops team and software teams. It's simple, not always. Sometimes it's very hard to configure, but when you run it, when it's already working, it's simple to change the manifest, create a new version of your process, or just deploy the new app. And finally, which very aligned with like first and second, it's actually what you see is what you get. So you have one manifest with 5 resources, you will have 5 resources, right? So no guessing here, no magic in between, except for the one happening on the cluster side, but that's not in your pipeline. Your pipeline does very simple job, and you see how it works. You can predict the result. The next question is when it just works. And here I mean not when the GitOps principle works. The principle works like arguably everywhere. It's usually when we talk about GitOps, we also mean some very simple common implementation in mind. Something like a process Rob showed us earlier. So when the simplest process works, I have just one tool, I manage everything in Git. This tool pull configuration from Git and push it into my target. Well, there are a lot of scenarios. The first thing is when you're just starting, the early days, you have maybe just a few teams, and you may be doing some POC for the new app or new platform. Then it works great. It's easy, fast to configure. Immediately, it's easy to push the changes. It will immediately appear on the target. So for early days and small project, great idea. The second option is when you have one app or one configuration and want to deploy it without changes, the exact same configuration, exact same app, without environments, but just simultaneously across, let's say, 500 targets. That's a typical cluster bootstrapping. I want to have monitoring app or logging app on my cluster, and for these scenarios, it works perfectly fine. Finally, if you have maybe many teams, but they're independent. One team works on this app, and this app has nothing to do with the other app, which the second team is working on. In this case, the simple process will do the job. And finally, just if you don't have yet that many apps, environments, and tenants, you still can manage the typical process. Yeah, maybe it will be a bit manual, but still good.
A lot of themes about this, is just to sort of really highlight that. A lot of the themes about this is about scale. It works well in small scenarios right off the bat.
Yeah, that's really true.
Let's talk about them. Let's talk about those limitations as you do start to grow. One of the most common problems people come up against when they start using GitOps is how to deal with sensitive variables. How do you deal with secrets? Almost every project we've got are going to have secrets of some sort, whether it's connection strings, API keys, passwords, that sort of thing. Sometimes infrastructure, sometimes application. GitOps doesn't really say much about this, right? Which is Good that it's not opinionated, but that can now be a problem because we now need to solve that. Let's have a look at what some of the options that are out there. In this example, again, I'll talk about it from the context of Kubernetes, since that's probably the most common GitOps scenario I find, but a lot of these principles are going to apply more broadly. So secrets are the native Git Kubernetes format. Basically, you base64 encode your secret, and you store that directly in your resource manifest. And when you push that to the cluster, it basically just makes use of it directly. Hopefully, as I explained that, it's fairly clear why that's not a good idea to store in your repository. The secret itself is just base64 encoded. That's like leaving the keys on the roof of your car at the shops. Not a good idea. So sealed secrets is a common pattern to sort of overcome that problem. Basically, what you do is you generate a public and private key. You store the private key in your cluster alongside with a controller, and you take your sensitive variable and you encrypt it with your public key. That encrypted value now you can, in theory, store in your repository, and when that gets into the cluster, the controller will take that private key, decrypt it, and it's sort of safe to use inside. Note that while it's encrypted, though, that password though is still out in the open, and you might say that mind that the recommended key size and algorithm has sort of changed over the years. At some point, something that we've considered secure could be easily brute forced. So why take a risk with something that, based on Git being one of its key strengths, is you keep those values around forever. You're potentially leaving those values for later decoding. Imagine if you told your clients that their password to the database was out there available to everyone, but don't worry because it's all encrypted. They'd probably ask why make it available in the first place, right? On top of that sort of hypothetical problem, you've got the more material problem of how do you deal with key rotation. So it's encrypted, but at some point you're going to need to rotate that public and private key. How do you deal with that? Unless you're rotating every single underlying password and cert, you've probably already got them stored somewhere else. That's potentially a big task, particularly as things start to scale. So one of the solutions to this that is becoming more widespread is the idea of external secret operators. So this is obviously a gross simplification, and there's some variance between providers, but the general principle is that you're storing some non-sensitive properties in your manifests that when they get into the cluster, the specific secret operator will pick up those values from your manifests, and using the internal keys, access your third-party key store and bring them into the cluster. And as I explained that, you kind of hopefully realize something, that now what we're talking about is storing some of these properties outside of your repository. The secrets themselves are not stored in the repository. Is it the case that we're not in GitOps land anymore? Actually, that's good. That's fine. This is still aligns with GitOps. Mind blown idea number 2. GitOps doesn't say anything about where that source of truth is, or that there is even a single source of truth. We often hear adherents talk about everything needing to be in Git as a single source of truth, but that's not really explain why that's a name. Indeed, GitOps itself, if you look at those practices, they don't make any mention of this idea of it must all be in a single source. So that's completely fine. Octopus solves the problem with secrets in a similar way to external secret operators. It simplifies things even further, though. All you need to do is provide in your relevant manifest an octostash templating variable. And since in this case, Octopus is your CD tool, it has the environment context available, and it ambiently applies it as part of the deployment. So it knows what value to pass in during the deployment. This is injected directly in and stored in the cluster without running any additional custom controllers inside your Kubernetes cluster. Really nice. Because ultimately, if I start with one manifest and I just push that to dev, that's all good and well. But at some point, I'm going to want to make some slight tweaks, say, to my production environment because I want more replicas or something, and I want to make sure that those changes sort of persist through the environments where they make sense. So how do we deal with that? A common mechanism that a lot of people started with was this idea of branch per environment, and that kind of feels fairly natural initially, right? Particularly as an engineer, it feels like like with Git flow. I make my changes to a feature branch, and that's the thing I'm testing until I'm happy and can fine for it to go to production. I merge to the main branch, and that's the thing that designates what goes out to production. The reality is, though, there's a big difference between what you're doing with the application code, where you're effectively resulting in bundling at once and moving around between environments, and in CD, where this environmental concept is exactly the place where that relationship matters. So it needs to be properly modeled. It actually creates a high risk of drift. In this scenario here, there's nothing stopping me from making changes in, let's say, staging after I've merged from QA, because at the end of the day, they're all just fundamentally Git branches. There's a high risk of breaking things that have been validated in earlier branches. Again, there's nothing stopping you from changing in production. And that creates potentially merge conflicts, because now I've made a change in production, which I need for the production environment. But when I merge that change from staging, I need to understand and only overwrite those values that actually have changed, as opposed to those that need to stay there for the environmental differences. It's also very high touch. So this makes it difficult for any sort of automation. And you've got security issues. So it's difficult to control who has access to the different environments across various different branches, and it completely depends on what tools your Git provider provides you. Repo per environment, that partially solves some of our permission problems. We can have controls on who can access what environment, but you've still got that risk of drift. You've got this complete disconnect between environments. Again, there's nothing stopping me from making changes in one that haven't gone through the other. And progression is a little bit unclear now. It's not really obvious to me or really enforced what environment needs to go out before the other. At the end of the day, it also doesn't really scale well. Again, as you increase the number of environments you've got, and you potentially multiple tenants, and that's per project, this can really get out of hand. Folder per environment is one that is a lot more common nowadays, and it's modeled by having a separate folder, typically within a single repository, where your CD system will watch for a single default branch like main and master, and that's where it reads from the different environments. The nice thing about this approach is you get the benefits of templating with shared resources. On the flip side, with shared resources, you've now got a new and novel opportunity to break things, where if I'm using some shared resource that staging and production are using, I need to understand that by making that change, I might be impacting production. Also, you need to start asking that question about what am I actually promoting? If I've successfully deployed staging, but that was 10 commits ago, when I come to then merge that into production, the commit that I need to merge is actually what staging was 10 commits ago, not the current one. The development pattern is also a little bit messy. If I'm a developer making a change in my feature branch and it requires some changes to my testing environment, I now need to either wait for that to merge into master so I can test it, or I need to make some changes in my master branch, because that's where my CD information is, that correlates with my application changes in my feature branch. This is partly why a lot of users will start to actually separate their CD manifests and application code into separate repos. It embraces that reality that the single repo shouldn't be the single source of truth. Again, scalability problems. As we add more and more environments, we've got more and more merge conflicts and things we need to deal with. Actually, Kit, you talk to a lot of customers. I'd be interested to hear what are some of the patterns you're seeing customers do in this space?
Well, I think the first one and the third one are the most popular. And as you said, exactly. So as soon as you have just few environments, I think people opt in the first one. And then as they grow, I see a lot of scripts, and then script triggering script and another script triggering these three scripts in sequence, trying to orchestrate that. And it can result in very complex permission control, like which script or which person can do what with each branch. So, and yeah, that can be, it works in the beginning, could be messy in the end, at the end. And then if you have a lot of, especially if you have tenants, like you have one cluster, for example, per customer, or you have North America, Oceania, Asia, and Europe region, in this case, you will opt into folders. But then again, you'll probably struggle with the same problem you described eventually. So I would say these are popular, great in the beginning, hard and get harder and harder as you grow.
Yeah, that's interesting. Yeah, and that follow from it's definitely seems like it's a popular one now, and it does make sense because this is something that like Customize and those other tools have really started embracing. There is a fourth way though, right? The Octopus approach to environments and environmental progression. It takes this idea and makes environments and environmental progression a first-class concept, since at its core, Octopus is a CD tool, and in a CD tool, these concepts are critical to the whole process. We've got as a way of managing that, we've got very granular permissions. So solving some of those permissions problems, flexible RBAC controls you can define on what environments and who can deploy. Again, it's made in the product as a first class concept. Templating, as you start templating different environments and defining them that way, where you provide the variables that are needed for each environment, you get limitless scalability. You don't have to deal with that problem of drift or merge conflicts. Environments and life cycles. Again, by modeling these as first-class concepts, you can sort of control them in a clearly defined and predictable way. You don't need to guess as to understand, oh, have I merged to the right environment because it's been validated there. And on top of that, you can actually automate it, right? With a lot of those Git-based approaches, the high touch that's involved with any sort of pull request means it's pretty unlikely you're going to be able to do that in a really automated way, which is kind of at the core of any sort of DevOps process, really. Releases and snapshots, and we'll talk about this a little bit further later, allows you to build once and deploy many times with none of those sort of poison merges that you kind of risk otherwise. Excellent. So we've talked about some of the potential problems in that space and how Octopus helps solve that. Now let's have a bit of a chat about some of the ways that people are, some misconceptions, I suppose, of GitOps and how leveraging Octopus will solve some of those missing pieces. Not only does it make sense, but aligns with some of those GitOps core tenets. So we'll start by talking very briefly about drift detection. Disclaimer, I know as I say that, it's not that I think in and of itself drift detection is a bad idea. What it does, though, is it just raises its own questions that are sometimes, I think, left unanswered. Now, continuous reconciliation, one of those core points that Kit described earlier, that's part of GitOps, can be summed up as sort of being two phases. The first, and I think the stage we kind of think of initially, is that idea of, I make a change in my repository, I've got a process which is sitting there watching that repository, and it gets pulled into my target. The second, though, to the right of that process, involves ensuring that desired state continues to hold true if any ad hoc changes are made to the target. So in principle, that part of drift detection sounds great, right? But I think it misses one of the questions that should be asked when drift is actually detected. So why was drift taking place at all? This potentially hides the question that instead we should be asking about the permissions and access to your system. Why are those unknown changes even happening to your system? A colleague of mine, Matt Casperson, made a really good analogy in one of his blog posts about this. Imagine you've got some guards at your factory, and one night they evict some trespassers, and you think that's great, they've done their job. My security still stands in my factory, all good. If that starts happening constantly, though, say multiple times a week, you're probably going to want to start wondering why you're having this problem at all, and if the occurrence of this is becoming a sign of some broader access problems in your facility. Drift detection isn't a bad thing, but one of the ways that sometimes lean on this too far is to use it as a tool to protect themselves when engineers need to get in and make changes to code. Engineers or ops personnel will sometimes be given access to the cluster to perform, say, maintenance tasks or update various components. Drift detection ensures that any accidental changes that apply to their application infrastructure can be rectified quickly. On top of this, sometimes the ability to turn off and on drift detection, or reconciliation in general, are made as first-class controls in some tools. And this allows for slightly more permanent changes. But this actually undermines all the controls and auditing that are some of the very core ideas and principles that GitOps are there to help us solve. With this in mind, at Octopus at the moment, we don't really put a huge emphasis on drift detection. Our focus is primarily on prevention. And that's why that rich security and permission model I described earlier is first and foremost ingrained into what we do. On top of that, Octopus actually allows maintenance tasks to take place through runbooks. And these are like the ops equivalent of deployment processes. These runbooks still operate within the boundaries and fine-grained security controls that allow you to define who can access your production infrastructure, but it really puts the emphasis on prevention rather than reaction. Another interesting topic to talk about is that distinction between CI and CD. So, think about how often do you think changes from your code and your application are flowing into your CI system? It scales pretty linearly with the size of your team, right? It could be tens or hundreds or maybe thousands over the course of a day. And we probably want a good number of them to flow through to a deployment, even if you're practicing continuous delivery and the changes end up sitting and waiting in the test environment. What about changes to your infrastructure manifest? Kit, how often do you think you'd be making changes to your infrastructure manifest?
Depends. So you can scale up, scale down, but generally speaking, I wouldn't expect more than once a week, every couple of days the most.
Yeah, exactly. I imagine maybe a couple of times a week if you're particularly active. In many cases, once you've got it stable, you're probably not going to touch it for months, right? So unsurprisingly, it's common for teams to rev their application changes at a different cadence and a different manner to their manifest changes. When you're using that single shared repository for this, though, and you're trying to chase that single source of truth idea, this can be tricky for you to hold in your app. Your CI tool generates a new artifact, and then something, either manual or automatic, needs to go back to that same repo and update the number baked into your manifest. When you're doing that, obviously make sure that your CD system doesn't trigger off another build because of that change. Otherwise, you're going to get caught in a loop, and that's going to get quite expensive. We see evidence for this realization in a lot of tools that we typically consider to be Kubernetes native, allowing the revving of images as an independent process from the manifest themselves. For example, Argo CD image updater allows you to change the image on your clusters independently of the manifest state. So when you start with a single environment, perhaps with a single engineer, it kind of works fine. Your artifact gets built, it triggers a new version update of your manifest, and ideally automatically triggers that reconciliation process to apply it to the cluster. All good. As soon as you have multiple environments, though, you now need to manually perform some sort of merge process between environments, opening up to all those risks we described before that can create potential bad updates. This manual and heavy touch part of this process means that as you grow, may start stretching some of that principle of least privilege. That effectively starts giving you access to configuration files in production. Everything like pull requests here introduces that risk, particularly once you start adding, scaling also your organization structure. Now you need more people to have access to more of those environments. Octopus solves this problem though with the first class concept of release. Bit of a side note, for a while there, I'll be honest, I was often wondering why customers were using Helm for internal applications. In my mind, it made a lot of sense for sort of distribution of a mechanism for libraries. I've since come to the realization, though, that Helm packages for internal projects are trying to solve this same or similar problem that an Octopus release does. It takes all the details for your deployment, your variables, your process, your templates, and snapshots them into an authoritative source of truth. And this is passed around in your CD system. And notice I didn't say single source of truth, it's just the authority. An Octopus release, however, takes that one step forward and not only defines what gets deployed, but through the capabilities of environments and lifecycles defines the where and the when. This concept guarantees the safety of that desired state moving forward, avoiding most of the risks we saw in those earlier cases. This feature allows you to practice GitOps actually in closer alignment to the core concepts of DevOps as well. The release definition is what allows you to really trust those automations and empowers your teams and policies that build them. The idea here is really focus on the right tools to build, test, and publish your code, and the right tools for deployment. So keep in mind that, with the spirit of the 12-factor app, we're all used to building applications once and using the same artifact across all our environments. That's a realization that I think the industry has come through for a long time. Now, really, we should be taking that property, though, and extending it to your CD artifacts, your manifests. There's no reason your declarative manifest should have to keep updating with every single build and every single commit that comes off your CD pipeline. That's really not necessary. So, with all this background in mind, Kit, can you have a bit of a talk to us about how you'd actually apply some of these practices at scale?
Yeah, so let's talk about how to configure Octopus to deploy to Kubernetes, and more about what we think you should keep in mind to make it simple, manageable, and also benefit from all the best practices we talked about before. So before we begin, let's imagine where these problems, like scale problems, would really hit you. Does mean that all the recommendations won't apply for any other scenarios. They do. It's just here you'll probably really feel the pain, and then the recommendations will really help you. So imagine you have 20 teams and they work on hundreds of services. So each team deploy a dozen of small applications, and these applications are expected to run on the same target, and even more, they expect to interact with each other. So imagine that you have multiple regions. Let's say you keep one cluster per region to decrease the network latency, for example. And then imagine that you have a sophisticated process, you have maybe a separate QA team, and you should promote your app and configuration through multiple environments, and then not everyone can just push it forward, but let's say QA engineer can push it to staging, and software engineer can push it on to QA. And then imagine that you have a separate team, because, well, obviously your configuration is now quite big. You have a separate team who manages CI/CD stack and also Kubernetes. Finally, you might think about using some other services like cloud native databases or something else to complement your Kubernetes. So not everything could be stored in Kubernetes. And then imagine you have some legacy. Maybe you still have some VMs running somewhere or bare metal machines. And maybe the other way, you have actually some modern apps which run only serverless. Okay, so does GitOps make sense for this scenario? What do you reckon, Rob?
Yes, very much. It still applies, right? This is exactly. I think if anything, this is exactly when GitOps kind of makes sense, right? It solves some of those problems.
Yeah, and I think the main thing here is all the benefits, like you can have a version, you can have immutable declarative configuration. All the benefits are even more important here because it's complicated. And when you have complicated scenario, then you want more visibility and control.
That's right. I mean, those simple scenarios where we're sort of saying GitOps, naive GitOps, kind of just works. To some extent, those problems don't exist because they're simple, right? Like some of that observability problem or that reproducibility problem. You've only got one environment, one person. To some extent, the argument could be that they don't matter as much. It's really those GitOps principles become really important as you scale. So solving them in the way that makes sense, that's kind of what's critical, I think.
That's fair enough. So, what do we recommend? First and foremost, make your project simple. Use one project per one app, per one service, and just don't try to pack a lot of steps into this project. We recommend having one main step, the actual deployment step, and you can add other steps like approvals, select notifications, other validation checks, but try to make it simple. If it's simple, it's easy to create another one, it's easy to manage, you know what's happening, you don't have to dig through like different steps interacting with each other. It's scalable this way. Second, think about steps which we already have in Octopus. Yes, you can Octopus powerful tool, you can run a lot of scripts yourself, but we have a few basic things for multiple scenarios like plain YAML, customize, and Helm. And in most cases, they will just work. And you also have other special features built in. So think about using them. Again, that will make your life way easier. And finally, in some cases, you will have to manage dependencies. For example, you have to update this app only with this app, or update them in a certain sequence, etc. For this case, again, don't use one project with multiple steps. Think about having a master project and just triggering your other project from this project, like a master or orchestration project. Will probably do a better job. Moving forward, when you think about real scale, we think about what if I'm adding my 501st microservice? How can I make it easy? And here we suggest just think about templates. So first and foremost, it makes sense to template your Kubernetes configuration. There are multiple ways of doing this. You can use Helm, you can use plain YAML, but we suggest thinking about Customize. So Customize being powerful tool allowing you to have overlays per environment or tenant, we can expand it even further and think about having one Customize for multiple apps. So what if you have an overlay per app type? Let's say this is an overlay for API, and this is overlay for database, and this overlay for something else. And then combining this with Octopus variables can allow you to modify it even further for a particular app needs. That's really powerful. So you don't have to replicate the same configuration again and again, and you can change the template on overlay once, and it will have impact on all your apps. Make your life a bit easier. Then, let's say you configure the customize step, create a step template, hide all the complexity, use Octopus variables like system variables to automate as many things as you can, and surface just a few app-specific properties which your software developers have to fill in when they reuse this template. That makes the job easy and prevent you from many potential mistakes. Finally, use configuration as code. It's great to have declarative Kubernetes configurations. It's even better to have also declarative project configuration. So you can have this source of truth and versions and immutable configuration. And finally, at the very end, if you think about scale, how you scale, think about using Terraform and maybe creating your fully automate creating the new projects in Octopus. Finally, when you think about environment progressions, as I mentioned before, think about using variables and defining app-specific, environment-specific parameters and secrets as variables. It's easy to manage. With configures code, it will be versioned, and you will have this one for variable source of truth on one screen, and you can see what exactly happening for each environment, what was deployed, and what's even better, variables can actually be scoped and became immutable as soon as you create a release. So you know which version of this variable was deployed with each release. And sometimes you want to have specific paths for different versions of the app. Let's say one version might be just for developers to test something and it should never end up in production. You want to prevent that. And other version should go straight through production and all the tenants. For this scenario, use lifecycles. So it will just eliminate some errors which people can make accidentally. Right, and in the very end, going back to the do detection, just try to not provide direct access to your clusters. There is really no need. So we have what we call object status for Kubernetes in Octopus, and you can see your deployment success. So you can verify what all the resources you expected were created and find some basic information about them. You can use runbooks, as Rob showed, for maintenance and debugging tasks. Again, no need to access the cluster, and because runbook steps can also be templated, you know exactly what happens, and you can provide to your software teams all the tools from centralized place. And finally, think about adding some ongoing monitoring and log collection tools to Octopus. So after deployment, you still know what's going on with the app without accessing the cluster directly. And that's about it. We have a lot of samples. You can follow the link and find examples of how you can configure Octopus with different cloud providers, with different tools like Helm, Customize, and plain YAML, how you can use variables, how you can orchestrate microservices. So it's all there, and just feel free to reuse it. Hope it's helpful. Finally, we do hope that you have something you disagree with from this presentation. And
I'm sure there'll be some things that people disagree with.
yeah, absolutely. Maybe like at every second slide. So, and that's awesome. So please, please, please share your experience with us. We want to learn from your experience. It will help us greatly to develop a better product. So please, if you don't mind, just having like quick
Let's
half an hour chat with our
let's have
team
that
to
discussion.
share
Have that
your experience.
discussion. Yeah.
Yeah, yeah, let's talk about it. So please don't hesitate, and we'd really, really appreciate meeting you and talking about Kubernetes and GitOps.